Welcome everyone to this Climate Change and Resilience Platform webinar. So today here in July 2019, my name is Pierre Banoori, Energy Specialist and Consultant, and I'll be taking you through the CARE Climate Smart PIIRS indicators. So this webinar's main goal is to explain how to enter data into these new PIIRS indicators, as well as provide recommendations to new processes to help collect the required data. Looking into the content of this presentation. So we will first start with some background and context. We will then go through the PIIRS Climate Smart indicators in a step-by-step process, finally ending with some recommendations. So some background and context over here. So currently, you have international and national plans to reduce emissions are wholly inadequate to keep global warming below 1.5 degrees Celsius and may lead the world to a highly dangerous 3 degrees Celsius warming this century. The last 4 years were the 4 hottest on record, and winter temperatures in the Arctic have risen by 3 degrees Celsius since 1990. We are starting to see the life-threatening impact of climate change on health through air pollution, heat waves, and risks to food security. The impacts of climate change have a devastating impact on the poorest and most vulnerable, undermining food and nutrition security and contributing to increased humanitarian emergencies. The burden of these impacts falls disproportionately on women and girls and will likely increase existing inequalities and vulnerabilities between men and women. Therefore, a tremendous level of effort is needed to stay within a global temperature increase of 1.5 degrees and to support the poorest to adapt to the adverse effects of the climate emergency. CARE is already working on the ground to support communities, particularly women, in their adaptation to the effects of climate change and is calling on governments to take responsibility and increase action to reduce greenhouse gas emissions and support adaptation efforts of the poorest countries. Our organization has received donations for climate change-related work. In fact, Greta Thunberg recently awarded us with a share of a prize she received in acknowledgement for our strong work on climate justice. CARE must continue in this direction and really walk the talk regarding its own greenhouse gas emissions and overall contributions to climate impact. This is why we have the new Climate Smart indicators. These will allow us to have an annual global overview of the total amount of greenhouse gas emissions generated by CARE. They will also allow us to have a global overview of the total amount of greenhouse gas emission reductions by CARE over consecutive years, and to have an overview of the types of measures developed by CARE offices to reduce and/or offset their emissions. On top of that, this will help generate information that supports reflection and learning around good practices to reduce emissions and about areas that require improvement and support. Now, all this data retrieved will be analyzed and results will be shared with all CARE offices in an annual report. And lastly, we'd like to inform you that CARE country offices are not obligated to fill in this PIIRS data this year. We, of course, strongly encourage you to report on your carbon emissions. But if you realize the process is impossible due to a lack of previously collected data, we advise you to take this as an opportunity to create and initiate the data collection systems and be prepared for data collection in fiscal year 20. So, if we go to the next slide, we have the overview of the Climate Smart PIIRS section. Here we see that they're divided to 4. We'll have the flights and greenhouse gas emissions during the fiscal year. We'll be looking into the fuel consumption for vehicles use in the fiscal year, the office energy consumption during the fiscal year, and finally the measures your office has taken to reduce and/or offset emissions in the fiscal year. If we look at the current PIIRS filing system, you will see, well, shown here. So you will see that we have our regular PIIRS system. If you scroll down, you will see section 6, the last section that has been added. So CARE's carbon footprint and climate smart practices. So this is where you will have to be entering the data. Now this will be helped by a legend situated on the right that will help guide you through the entering of this data. If we go back to our presentation and we have a quick zoom onto this section 6 of CARES Carbon Footprint and Climate Smart Practices, we see that 4 sections can be distinguished, which we'll be taking you through in this presentation. So step 1 are the flights and greenhouse gas emissions during the fiscal year. Step 2 will look into the fuel consumption for vehicle use during the fiscal year. Step 3 will look into the office energy consumption during the fiscal year. And finally, step 4, which will look into the measures taken to reduce or offset emissions during the fiscal year. Most of all, there is a document, the CARE Carbon Footprint and Climate Smart Practices Guidance Note, which will help guide you through the entering of this presentation. This material is available at the hyperlink situated below. We have to look now at the step-by-step process that you have to take in order to enter this information. So firstly, you will start by reviewing the Climate Smart Guidance Note. And upon so, you can gather all available data and documents that will be necessary for input. Now, gathering the data in most cases means retrieving the specific data from a certain department of your office, such as, for example, it's been seen that vehicle fuel expenses, in order to know how much gasoline, diesel, or other fuels have been used during the year, can be retrieved from the financial department of your office. Duration-wise, the whole process might be lengthy, but if you are doing it for the first time, especially. However, once a base is built and if performed regularly, it will reduce the amount of time spent. But once you have gathered all this data, you must then process the data and documents, go through PIIRS and fill in the required data, and then share and discuss optionally with relevant team members on the entry and input of this data into PIIRS. So moving on to step 1. Flights and greenhouse gas emissions during the fiscal year. In this section, it is important to report the number of flights paid for by your office for both staff and consultants. Now, each CARE office is asked to report on the gathered information of all its different offices in the country. For example, CARE USA will report on the emissions related to its Atlanta headquarters and all the sub-offices in the USA, but it will not report on the emissions of country offices it leads in the Global South. CARE Uganda, for example, will report on the emissions of its national office in Kampala and all its sub-offices in Uganda. Taking a closer look now at the first box that will have to be filled. So these consist of the number of flights and hours of flying. So firstly, the first input will have to be number of flights under or equal to 2 hours of flight time. The second one will relate to numbers of flights over 2 hours of flight time. Then you have also the total number of flights during the fiscal year. This, however, as you can see, is a blue box compared to the other orange boxes. This blue box is calculated itself in PIIRS, taking account of the 2 boxes of under or equal to 2 hours of flight time and the flights over 2 hours of flight time. Lastly, you have the total number of hours of all flights during the fiscal year. So attention though, when reporting flights that have intermediate stops, consider them as one single flight and include the total hours of flying. For example, if you had a trip that consists of a 1 hour long flight, an intermediate stop, and another flight of 6 hours, you should report this as one flight over 2 hours. This should thus not be counted as 2 separate flights. For example, as one flight under 2 hours of flight time and another of over 2 hours of flight time. We then go to step 1.2. Here we'll be looking into the total amount of greenhouse gas emissions from flights that were supported by your office. So it's the total amount of GHGs in tons of CO2 equivalent from flights that were supported by your office during the fiscal year, as well as which method or calculator was used for determining the amount of greenhouse gas emissions. Of course, you can calculate your office flight emissions yourself with an online tool or ask an external organization to do it for you. The most important thing is to keep in mind is to be consistent. So use the same calculation methodology over the years. If you choose to do the calculation or emissions yourself, it is recommended to use the online calculator Atmosphere, of which The link you can find in this gray box on this slide. We will show you now what Atmosphere can look like. Going on to Atmosphere, this is their homepage. You will go to Offset Flight. You then scroll down and you will see what the input to calculate your flight emissions looks like. Here you will select a departure airport, for example, Paris. You will have an arrival airport, Dubai, and you can add or remove intermediate airports. And here, for this example, we shall put Frankfurt. You can also choose for each flight, the flight class. You can choose the flight type, so chartered or scheduled, and the aircraft type. So you can also choose the number of flights. This is a round-trip flight, keep that in mind. And you can also choose the number of persons on each flight. By going down, you now may calculate. Upon calculation, you will receive a result here pictured in red. So it is your flight emissions per person in kilograms. Here we see that for this flight, it was 2,471 kilograms. Going back to our presentation, a few recommendations, because as you can see that calculating the CO2 emissions for all your flights at once can be a very tough and lengthy task, as you will have to input the information that we just showed you for each and every flight. So experience has shown that it is preferable to monitor emissions on a continuous basis, such as in a live spreadsheet that is updated regularly, as the one pictured here. We will then move on to examples. An example as a case study. So here, your office, for example, your office has to report flights and greenhouse gas emissions for fiscal year 2018. Let us assume your office has taken 200 flights in fiscal year 2018. So after processing the data and documents, you may tackle the PIIRS indicators. So now, say you distinguish between all flights and you find that you have had 50 flights under or equal to 2 hours of flight time, and 150 flights over 2 hours of flight time. So this then is input into PIIRS. You can distinguish them. They put input here, and upon this, PIIRS will calculate automatically that you have had a total number of flights of 200 during this fiscal year. You then must calculate the total number of hours of all flights during the fiscal year. This is a different thing, but for example, you had a flight of 2 hours, you had a flight of 4.5 hours, another of 3 hours, another of 9 hours, and so on, and so on. Say, in this example, we get an added sum of 680 hours of total hours of flights, of flight time. So then this is input into PIIRS in this box pictured here. Moving on to the example for the second part of this filling in of the PIIRS process. So here we'll have an example of the Atmosphere results. In this example, we took Paris airport as the departure airport, going via Dubai, and the arrival airport being New Delhi. For each flight, it was an economy flight, it was a scheduled type flight, and the aircraft type was an Airbus A330-300. Then this is a round trip from Paris to New Delhi. So for this example, we find that the CO2 emissions per person were in kilograms were 3,406. But notice that this result is in kilograms of CO2 equivalent. To input this data into PIIRS, you must first be converted into tons of CO2 equivalent. Knowing that 1 ton is equal to 1,000 kilograms, thus you must divide Atmosphere's result by 1,000 in order to get a result in tons of CO2 equivalent. So once converted, this example results in 3.406 tons of CO2 equivalent. Of course, again, I'll remind you that you have to do this for each and every flight. In this example, we are just picturing it for one flight, but you will have to do it for all. And so thus the input here for this example, if we move on to the next slide, it was 3.406 tons of CO2 equivalent. But of course, keep in mind that it will probably be much bigger, as this is just for one flight, and you would have to sum all your flights and put that result into this box. And of course, you describe as well the method or calculator used here, which was atmosphere.de. We then move to step 2. looking into the fuel consumption for vehicle use in the fiscal year. So this section allows for the estimation of emissions from vehicle use by your office. And note that only vehicles used for professional purposes by your staff and consultants should be considered. This question does not include daily office commuting by your office staff with their personal vehicles. Also, taxis, Ubers are also beyond the scope of this calculation because collecting the required data does not seem feasible at the moment, so it is not included for now, even if we acknowledge that it can represent an important share of emissions for your office. However, if they do represent a large usage for your office, you might consider options that could be promoted to help reduce your office emissions related to taxi or Uber usage. Also, we have to remember that when speaking of vehicles, this means all kinds of transport besides airplanes, of course, that operate under PIIRS name. So looking at the PIIRS input for step 2. Here it is one of the smallest sections in this PIIRS Care Climate Smart PIIRS section, and it looks into the number of liters of gasoline, diesel, or other fuels that were consumed during the fiscal year. Now, of course, first input in the first box will be the amount of liters of gasoline consumed during the fiscal year. The second will be the amount of liters of diesel consumed during the fiscal year. And the third will be amount of liters of other fuels. Other fuels can be such fuels such as biodiesel, ethanol, liquefied petroleum or liquefied petroleum gas such as LPG, even methane, so compressed natural gas, or hydrogen. Now, if you have all this data already in liters, you can directly enter the values into PIIRS. If not, you will have to convert your values into liters. You will most likely have this data in terms of amounts spent on fuel in the fiscal year. In order to proceed, you will have to divide the amount spent, either so in US dollars, euros, or local currency, by the average cost of gasoline, diesel, or other fuels in said currency per liter of that fiscal year. This is visualized here in the formula in the orange box. However, moving on to the one recommendation we can do for you here is to keep track of all fuel expenses on a regular basis, such as with flights. So this allows to input the actual fuel price at the time of the fuel purchase, because obviously it will vary during the year, and using an average, as we said just now, is good, but we can always do better. So experience has shown that it is preferable to monitor emissions on a continuous basis, such as in a live spreadsheet that is updated regularly. Here we see, for example, in this fuel use form, we have the date of fuel purchase, the amount, the fuel type, the fuel price, local currency per liter, and that calculates then the amount of fuel in liters. Moving on to the example. Say your office has 3 vehicles registered under its name. The financial department provides you with the fuel expenses due to vehicle use. $500 for fiscal year 2018, of which $300 are for gasoline and $200 are for diesel fuel. We will use the local average price of gasoline and diesel per liter during the fiscal year 2018 in order to calculate the amount in liters that was consumed. Let's assume that the prices were $1.4 per liter of gasoline and $1.2 per liter of diesel. We then calculate. So 300 divided by 1.4 is equal to 214.29 liters of gasoline, and 200 divided by 1.2 is equal to 166.67 liters of diesel. We then input this into the PIIRS as shown here. There were 0 liters of other fuels, so that is why we have a 0. We will then go into step 3. So this looks into the office energy consumption during the fiscal year. This section allows for the estimation of emissions from energy consumption in your office during the fiscal year. This section does not take account of home office working and its eventual energy use. Here we look clearly into the care office energy use. Moving to step 3.1. So following the theme that was just showed in the cars, here we'll look at the number of the vehicle use. We will look at the number of liters of gasoline, diesel, or other fuels consumed by generators to power the office. So this section is specifically for offices that use fuel-powered generators to provide energy to their offices. So just as said, similarly to the input for fuel consumption for vehicle use, data input is required for the fuel consumption for generator use. Now, we look into the amount of liters of gasoline consumed by generators during the fiscal year, the same for the liters of diesel, and also the amount of liters of other fuels consumed by generators. Now, if you have this data already in liters, it can be input directly into PIIRS. Otherwise, it will have to be converted, such as with the vehicle fuel use. However, there is one more important thing to pay attention to here, which we'll show you on the next slide. It is that if there is a generator for the whole facility where your office is, you must identify how much of that generator usage corresponds to your office energy needs. So we can use the following formula to calculate your office's respective generator fuel consumption. The key factor here, the determining factor, is having the office surface in square meters divided by the total facility square meters, well, surface in square meters. That is the main factor, which will then multiply by the total generator fuel consumption of the facility in liters, which will then give you a result of your office's generator fuel consumption. We will then move to the next section, which looks into the office energy consumption during the fiscal year, but looking into the amount of kilowatt hours of electricity consumed during the fiscal year, the CO2 intensity of your electricity provider in grams of CO2 per kilowatt hour during the fiscal year, and the amount of cubic meters of gas consumed during the fiscal year. Firstly, focus on the amount of kilowatt hours of electricity consumed during the fiscal year, which is shown on the next slide. Here, we'll look at the total amount of kilowatt hours used by your office which should be available in the metered electricity consumption or in your utility bills, specifying consumption either in megawatt hours or in kilowatt hour units. If your data is in megawatt hours, you must convert it into kilowatt hours by multiplying by 1,000, since 1 megawatt hour is equal to 1,000 kilowatt hours. Secondly, we look at the CO2 intensity of your electricity provider in grams of CO2 equivalent per kilowatt hour during the fiscal year. So sometimes you might have energy providers that indicate CO2 intensity information in their electricity bills or on their websites, as shown on this slide. For example, here you have Electric Ireland, the fuel mix disclosure label, which shows that between the period of January 2013 and December 2013, the electricity supplied by Electric Ireland had CO2 emissions of 535 grams of CO2 equivalent per kilowatt hour. Now, if this is not disclosed in your utility bills or on your electricity provider's website, you may also contact your energy provider to receive this information. Also note that in some countries, the term CO2 emission intensity is used, while in other countries, CO2 emission factors is used. Now, moving to the next, if your energy provider cannot give you this information, does not have it on their website, not in the utility bills, or even upon contacting, they cannot provide it, you can provide us with the CO2 equivalent emission factor indicated in your national energy grid. And the following source is recommended to retrieve this data. And this is shown in this hyperlink here in the box, where we will show you it is an IGES file, which we'll show you now. So upon opening the file, you will fall on the Guidance tab. You must go to the third tab, the Summary EF from CDN. Upon going to this tab, you can go find your country in the country list, but you must also focus on looking at the operating margin EF column, so column G. And this is the operating margin EF in brackets average. And this is where you may find your country data. Now, this data, you must notice that it is in tons of CO2 equivalent per megawatt hour. Coming back to our presentation. So, and to the next slide. So, as we saw on this data, if your data is not in grams of CO2 equivalent per kilowatt hours, which is the unit which must be entered into PIIRS, you will have to convert it into the latter. So say, for example, such as with the source, the IGES file that we just showed you, if that source provides you your CO2 intensity in tons of CO2 equivalent per megawatt hour, you must multiply this by 1,000, such as pictured here in the formula, to get a result in grams of CO2 equivalent per kilowatt hour. If your source provides you your CO2 intensity in kilograms per kilowatt hour, you must still multiply this by 1,000 to get it into grams of CO2 equivalent per kilowatt hour. Moving to step 3.2.3, the number of cubic meters of gas consumed. So this looks into the amount of cubic meters of gas consumed during the fiscal year. This question provides an overview of the total amount of cubic meters of gas consumed by your office, for example, for heating and cooking. Gas consumption can correspond to different types of gases: natural gas, propane, butane, or liquefied petroleum gas, LPG. But the total amount of cubic meters of gas used by your office should be available in the metered gas consumption, such as the electricity or utility bills, specifying consumption in cubic meter units. So gas is usually always reported in cubic meters. However, if it is not, you must convert your value, your unit, into cubic meters. And here are some examples of some conversions. So if your gas consumption is reported in kilowatt hours, you must divide the value by 11.36 to get a value in cubic meters. If your gas consumption is reported in cubic feet, you must multiply the value by 0.0283 to get a value in cubic meters. If your gas consumption is reported in BTU, in British thermal units, you must multiply the value by 2.817 to the power of 10 minus 5 to get a value in cubic meters. You may also use an online gas unit converter, such as the recommended one here, the unit-converter.gasuni.nl, where you must select a gross calorific value, which is a GCV, of 40 megajoules per cubic meter. We'll now move on to an example of this, of the gas use, of the energy consumption of your office. So your office has to report its energy consumption for fiscal year 2018. The financial department gives you information. The electricity meter has shown that 1.2 megawatt hours has been consumed in fiscal year 2018, while the gas meter has shown that 56 cubic meters of gas were consumed. On top of this, 300 liters of diesel have been consumed by the generator. But the generator is shared within the building, providing energy to other offices as well, beyond our own care office. So first we see electricity is 1.2 megawatt hours for fiscal year 2018. So this is not in the correct unit. You will have to convert this into kilowatt hours. We convert it into kilowatt hours. That is equal to 1,200 kilowatt hours and gets input into PIIRS. Afterwards, we also notice that 56 cubic meters of gas is reported. This is in the correct units and can be directly put into PIIRS. As shown here, we then input the corresponding values into their corresponding entry points. Moving on, we see that now we must identify the CO2 intensity of our electricity provider. So in grams of CO2 equivalent per kilowatt hour. So your electricity, say in the worst case scenario, that your electricity bill does not show this information, and upon calling your electricity provider, they are unable to provide you with this information. You must then use the IGES Excel file, which we'll show you now. So you open the file, you scroll down, you find in the third tab, Summary EF from CDM, you highlight column G, so the operating margin, EF, average, and you look for the country where your office is located. Say, in this example, our office is in Guatemala, we find thus that the value is of 0.771 tons of CO2 per megawatt hour. So this is not in the correct units for the PIIRS system. We must then convert it. So taking that conversion formula into account, 0.771 times 1,000 is equal to 771. Thus, the CO2 intensity of your electricity provider is 771 grams of CO2 equivalent per kilowatt hour, which gets input into the PIIRS system, nice and well fitting between the two other data. We then move on, going to the generator usage. So here there are 300 liters of diesel that have been consumed. However, this is the total for the whole facility and not just your office. You must identify how much of this total refers to your office. You must use the following formula. So say your office size is 400 square meters, while the whole facility size is 1,600 square meters. Thus, what we do, we take the formula, 400 divided by 1,600, multiplied by 300 liters of diesel, that equals 75 liters of diesel. So your office has thus used 75 liters of diesel due to generator use. And that data gets input nice and well into its corresponding entry point. We also have 0 liters of gasoline consumed by the generators and 0 liters of other fuels. So we have a final completed table which looks like this. We will now move on to step 4. So these are the measures your office has taken to reduce and/or offset emissions in the fiscal year. This section allows for an assessment of the measures your office has taken to reduce and/or offset emissions in the fiscal year. It also allows to assess experience, receive feedback, and innovate towards new and better solutions. Looking into the first step of this step 4. So awareness raising among staff about the climate change impact of each category, so flight travel, vehicle use, or office energy consumption. Here you may select yes if your office implements measures to create or raise awareness among staff on the impact of their behavior on the climate. So this can involve things such as setting up green teams within the office, sensitization training, installing and storing a code of conduct, having environmental reports, or even internal campaigns on the impacts of flight emissions. Moving on to step 4.2, we have the application of alternatives or measures to reduce greenhouse gas emissions from each of the categories. So here you may select yes if your office implemented alternatives measures that reduce greenhouse gas emissions from each of the categories. So for an example, for flight travel, you may have checklists for staff to consider before deciding to use flights. You may have stricter travel authorizations in place, or the promotion of use of trains, buses, or boats, even vehicles, instead of using planes. You also have the creation of virtual spaces for meetings instead of having flight travel. Regarding vehicles, you might have more promotion of public transport, the promotion of car sharing or carpooling, even bicycle usage. And finally, for office energy use, you may have examples such as installment of more energy efficient lighting, equipment, or even motion sensors. You can even set the office equipment or HVAC, which is the heating, ventilation, and air conditioning system, into energy saving modes or completely shut them down during off hours. You may produce or purchase your renewable energy, and you may have the promotion of paperless offices and reduced printing of reports and emails. Going to step 4.3, we have application of reduction targets for each of the categories. Here you may select yes if your office has set a long or short-term target to reduce emissions. So the reduction target should refer to a baseline year and should strive to reduce emissions in comparison to that year by a certain percentage. For example, you decide you have a target that says you must reduce your greenhouse gas emissions by 10 or 20% by year X. So these reductions especially should be overall or absolute reductions, meaning that the absolute amount in tons of CO2 equivalent should be reduced, independent of increases in staff or in operations. Now we go to the application of a carbon budget for each of the categories. Here you may select yes if your office applies a carbon budget to reduce emissions for each category. Now, a carbon budget can be office-wide as well as it can be individual-specific, so with different carbon budgets depending on an individual's role within the organization. The intention of a carbon budget should be to limit an office's emissions. It should decrease year to year in order to drive more and more carbon reduction achievements. Staff are then being issued carbon budgets, which they can manage at their discretion. The decision of whether or not to undertake a particular trip becomes a trade-off against their future allocation for the year. So management would receive reports of carbon expenditure against budget and analyze variances and ensure that departments stay within the budget. Finally, we have step 4.5. So this one looks into the offset of emissions through internal funds or external parties. So here you may select yes if your office compensates for unavoidable emissions for each of the category. Because as we know that even though reducing emissions is the best way to limit one's carbon footprint, it is important to take responsibility for the emissions care offices produce. Using credible carbon offsets from known projects that have high social impact and environmental integrity is better than doing nothing at all. Compensating for emissions can either be done through an internal fund or external parties. In both processes, some aspects must be taken into consideration for offsetting your office emissions. If you're using external parties, you should definitely look into gold standard offsets, which have strict requirements for sustainability, local participation, and proof that the project is truly additional to business as usual. You may also look into retiring offsets, such as removing carbon credits from markets where there is a finite supply of permits to pollute. This is notable in the EU. So here your office should always take into account the fact that land-based offsets such as tree planting might not always be the best option, as they are by their nature temporary, as trees die in time, emitting the carbon they have absorbed back into the atmosphere. You have then the option of having internal funds. So it has been proposed that CARE sets up an internal project for offsetting. Several offices already do this. Currently, the CCRP is working on this, and you will receive more information in time through the CCRP quarterly newsletter. This CARE project should be prioritized for offsetting your office emissions once it is in place. Finally, we have 4.6, consisting of other measures, because of course, there may be other measures that your office is implementing in order to reduce its carbon footprint. If that is the case, please describe here any other initiative taken in order to reduce your greenhouse gas emissions. We now move on to the recommendations. So as we saw throughout this presentation, experience has shown that it is preferable to monitor emissions on a continuous basis using a live spreadsheet or database, rather than calculate emissions in one large annual number crunching exercise. Not only does this make the task more manageable, but it also keeps the topic alive and increases staff's awareness. So here, such as the filling of forms regularly to avoid the number crunching exercise. You can even introduce a travel form that keeps track of CO2 emissions as soon as flights are booked or taken. And for the office energy use, a good recommendation is to change your energy provider for a cleaner one that is less CO2 intensive. Finally, a reminder that there is material available to help you and guide you through the entering of data into this PIIRS Climate Smart section, such as here, which is the CARES Carbon Footprint and Climate Smart Practices in PIIRS, the guidance note, and this material is available at the hyperlink shown below. I'd like to thank you very much for attending this presentation. And of course, we're open for questions. If you have any feedback on this webinar or reporting CARES Carbon Footprint and Climate Smart Practices in PIIRS, the guidance note, or even the PIIRS Climate Smart indicators themselves, please contact Martina Luskova at carenederland.org. Of course, if you post a question in the help desk or PIIRS email, we will find the right person to answer your query. Thank you very much.